In this video, we'll go over the gases experiment. So to access this experiment, go to eCampus. You'll see supporting information for this experiment. Please read that. And then you'll see the two experiments. This is part 1, this is part 2. So to access every Beyond Labs experiment, we go through eCampus like I am doing. And then you can open the experiment. You have a short video, please watch it. It makes you familiar with what to use in the lab. And then there is the procedure in there, and this is your experiment. So we're going to open this in a new window. And let's put them side by side so that it makes it easy for us to switch from the procedure. And this is the procedure, and then you're going to fill your data in here and answer some questions, and then this is the experimental setup. Okay, so it's going to open into it's going to open either into this page, or you can zoom out like this. So this is how you zoom in and then you zoom out. Okay, so our experiment is for the first one, it's Boyle's law. And by definition, Boyle's law shows the variation in volume versus a pressure. And if you look at the supporting information, I did explain Boyle's law, and I said that it states that the pressure and volume, these are inversely proportional to each other. So as you increase the pressure, as you decrease the volume. So if you increase the pressure, you're going to compress the gas molecules and the volume is going to decrease. The relationship between the volume and the inverse of the pressure is a linear relationship, but we don't need to plot any of the graphs in this experiment. Okay, we're going to study the difference of Boyle's law for real gases versus ideal gases. And to start to define an ideal gas molecules, they assume to have no volume and no intermolecular forces. And they follow this formula: PV is equal to nRT. N is the number of moles, R is the gas constant, and T is the temperature. So if I make the temperature constant and the number of moles constant, the R is constant, which is 0.082. So I would assume that PV is equal to constant. So when I am analyzing ideal gases, the product of the pressure versus the volume is always constant. It will not change for ideal gases. This is different than real gases. Real gases, on the other hand, they do occupy definite volume, and the intermolecular forces exist between the molecules. So I would assume that real gases, they deviate from the ideal behavior when the temperature is low and when the pressure is high. So if I'm looking at the PV product, the PV product should be affected for real gases. As the pressure increases, normally the pressure and the volume products, they are going to decrease slightly. So with this said, with this experiment, you are going to open up this page, and it's going to set at a number of moles 0.3. It tells you over here that it's filled, the balloon is filled with 0.3 moles of ideal gas. The ideal gas that we are using is the cylinder, which was over here. This is ideal gas 1. And let's say, for example, if you, let me return the stain. Okay, so let's say if you open your lab, and you would see something like that. So what we're going to do over here is that we are going to press on the ideal. It needs to be an ideal gas. This is our first setup, and it's called ideal gas 1. The molecular weight for this ideal gas is equal to 4. You see here, this ideal 1 molecular weight is equal to 4. So you're going to press on that. Okay. Now, normally I assume that when you open this lab, it's going to be directly ideal gas number 1. But if it is not, then this is how you do it. In there, the number of moles is 0.3. This means that the balloon is filled with 0.3 moles of the gas. okay? And then it says that the pressure is 1 atmosphere. So it's going to set it for you at 1 atmosphere. And the temperature to be, let's see, the temperature here, it says that it's 298, okay? And the volume is that much. So that is going to be the first one. We're going to go ahead and save the data in there. And it says that you would need to save your data in the lab book. So in order to do this, you can hit on the lab book over here. You shouldn't see anything. This is my data. So what we're going to do is we are going to put ideal gas. So every gas that we are going to work with, we are just going to name that. This is ideal gas 1, and then we're going to hit submit. So that all the data that we are going to collect now, it's going to be for ideal gas number 1. Then we're going to go into the live data. Just make sure that it's always saving in there. So in the live data, we're going to click the save data, and we are going to start recording the pressure, the volume, the temperature, and end data to the lab book. We're going to go ahead and increase the pressure from 1 atmosphere to 10 atmosphere, 1 atmosphere at a time. So here you go. So from 1 to 10. Now, according to Boyle's law, as you increase the pressure, as you decrease the volume, okay? And the data that you are going to record, it's going to be here. So for pressure 1, record this volume there, okay? And then you're going to multiply those two together and get the PV. We're going to do pressure 3, pressure 6, and the pressure 9. Well, actually here in the procedure, it tells you to go from pressure 1 to pressure 10 atmosphere, but it doesn't, there is no place to record all the data. So we're going to go pressure 2. There is no place to record the pressure 2 over here. It's going to be pressure 3. So we're just going to skip 1 every time. So that is going to be pressure 3. Notice the volume is decreasing. Okay, so you're going to put that volume in the table and keep doing this there. Pressure 5, pressure, did it say 7? Okay, pressure 6, I skipped that, and then pressure 9. Okay, well, you're going to see that the as you increase the pressure, the volume is going to decrease. Guys, the volume has to be in liters, not in mils. So make sure whenever you put your volume in the table, it has to be liters. So you're going to divide by 1,000. Okay. So let's see over here. You're going to do the same thing for ideal gas 8 in there. So we are going to return the tank. We're done from the first ideal gas 1, right? So we're going to return the tank. We're going to save the lab. And then we're going to go into the lab notebook in there. So here you go. We're going to go into the lab notebook, and we are going to write ideal gas. Actually, this step is not very important, but because it makes it easy because you will be recording all your data. So let's say if you forgot what was your numbers, you can go back and check in there. We're going to go into the live data. And it says that always make sure that you are choosing the ideal gas, and they want ideal gas number 8 with the molecular weight 222. This is ideal gas number 8. So we're going to go ahead and press on that. Okay. This is going to be the tank. And the number of moles is 0.3. Now, let's say, for example, if the number of moles they showed up on your side to be like 0, for example, you gotta fill the balloon with 0.3. So to fill it, you just open the valve. Okay, and as you open the valve, the number of the moles is going to increase. Okay, so I'm just gonna leave it like that. Here it's just let me reset it. Let me reset that. Okay, and now I'm just gonna go ahead and open the valve and make sure that it is 0.2. You don't have to do this. You don't have to do this if your number of moles is the right number of moles as the given, But in case it is not, this is how you do it. You open the valve and you fill your balloon. This is for a different ideal gas now. So let's go ahead and save the lab. And it says that my number of moles, my pressure, we want it to be 1 atmosphere, okay? So make it 1 atmosphere. We're going to start with the 1 atmosphere. Start exactly at 1 atmosphere. Okay. And then this is going to be 0. Here you go. So at 1 atmosphere, this is the volume, and this is the temperature, and this is the number of moles. We're going to do the same thing. If you look at the data table, it says like we want the pressure from 1 to 10. So we're going to record 1, 3, 6, and 9. So let's go ahead and do that. So we're going to record the pressure 1, pressure 2. Notice that the volume is decreasing. I mean, you can go ahead and zoom in into the balloon, and you can easily see that the volume is decreasing. This is pressure 3, 4, and as you go all the way until it reaches the pressure of 10 atmosphere. So this is going to be for ideal gas number 8. And then we're going to open the presets. And now these are ideal gases. And as we said, for ideal gases, the PV is equal to a constant in there. And you guys, for ideal gases, it doesn't matter the molecular weight of the gas. So by definition, an ideal gas, a 1 mole of an ideal gas, any type of gas, whether it's a hydrogen, helium, ammonia, notice all of these, they have different molecular weights. So a 1 mole of every ideal gas always occupies a volume of 22.4 liters at a temperature of 273 and a pressure of 1 atmosphere. You can actually test that in the actual experiment in there. All of these are your ideal gases. So I would go ahead and change between those ideal gases and test each at a temperature of 273 and simply a pressure of 1 atmosphere. Your volume for any of those gases has to be 22.4 liter. But the problem with this one is that the oven is not very big enough. So the maximum number of moles that you can fit into that is 0.5 moles, which is around 11 liters at pressure of 1 atmosphere. So if you multiply this, it will be 22 liters in there. Okay, 22.4 almost liters. So anyways, this is how you go ahead and work the first part of the experiment. So let's see over here if we missed anything. Now for the real gas. So you recorded ideal gas 1, ideal gas 8 data as the pressure increases, as the volume decreases in there. And what you're going to notice over here is that for ideal gases, the PV will remain constant. This PV will remain constant. This is going to be different than the real gas. So for the real gas now, for that part, you're going to go into the presets and you're going to choose, I believe it says like the balloon experiment nitrogen. So we're going to do that in there, and don't worry about the sound, you know. So once you choose the balloon experiment nitrogen, it's going to open up exactly pressure 1 atmosphere, temperature, and the number of moles is 0.1 moles in there. So we are going to make it 0.3 moles. So they are asking me 0.3 moles in there. I would suggest that you do this like that. You go back and you open the valve. Don't work into these arrows in here because there might be a possibility your balloon is going to burst. So I would open the valve in there. Okay. You can decrease that. Here you go. Okay, and we're going to do now exactly the same thing. We are going to change the pressure, And we're going to monitor the variation of the pressure and the volume. As the pressure increases, as the volume decreases, we're going to do exactly the same thing. We are going to record the pressure of from 1 to 10 and in odd numbers, and the table as in the other parts over there. Pressure 1, 3, 6, and 9. You're going to record the volume, and again change the volume into liters, please. You're going to multiply the pressure times the volume, and you're going to get the product. You are going to notice that in real gases, the PV product is affected in there. When you're going to see that as the pressure increases, the PV product is going to decrease, but it's going to decrease slightly. Okay, you're not going to see that much difference, but you're going to see that it's going to decrease slightly. Okay, so this is going to be for this part of the experiment. Now the second part of the experiment. Now for the second part of the experiment, what we're doing is same thing, but now we are going to compare the real gases versus the ideal gases. So we're going to access again from eCampus, and we are going to I believe is the same video as the one earlier in there. There is one question in here that you can answer, and to answer those questions again, refer to the supporting material. Okay, I should have opened this in a new window, but I can take it out, make it a new window, and let's put those two together. Make sure always that the experiment page, your lab setup, is always bigger than that of your procedure, because you would need all of this space in there. Okay, and then start reading the procedure and following that. Now this one over here, you are going to compare different ideal gases versus real gases. So as we mentioned, real gases, these are molecules that occupy a definite volume. And if they occupy a definite volume, the molecules are going to be so close together, right? So the intermolecular forces, they do exist between those molecules in there. So the energy is going to be high between those molecules. You're going to see that real gases deviate from ideal gas behavior, especially at the low temperature and the high pressure. So, okay, so we're gonna start with ideal gas 1. So I believe this one is ideal. It is ideal gas 1. Let's make sure it's ideal gas 1. So this is gonna be my ideal gas 1. The number of moles is 0.1, as it's stating in there. You will change the temperature and the pressure. So now we're gonna vary the temperature. We're gonna vary the pressure. Since we're working with ideal gases, you guys, ideal gases go by the formula PV is equal to nRT. So now we're changing the volume, the pressure, and I believe the temperature as well. Okay. So we're going to follow the table. We're going to follow the table in there, and the table is going to tell us exactly what pressure and temperature we need for ideal gas 1. Okay, so we're doing ideal gas 1 in there. We need a pressure of 1 atmosphere, and we need a temperature of 10. You just go ahead and record the volume. Guys, FYI, in the first part, it says that you need to record your data and then transfer it into an Excel sheet. We are not doing this. So do not transfer anything to an Excel sheet. You don't need that. You can just pick your numbers straight from the experiment and then put it in the table. Okay? We don't need any plotting. We don't need any Excel sheet. So you're going to put your volume in there, and then after this, we're going to go ahead and increase the pressure. We're going to go ahead and increase this to 15. Oh, that is 30. You got to pay attention. Don't increase the pressure too much, because your experiment is going to burst. In there, let's make sure. So this is 0.1 moles, like it barely has has any in there. Let me open the valve a little bit just to, okay, it is not interacting. So if it is not interacting, there is something wrong. So I'm just gonna reset it. Okay, so, and then I'm gonna return this to the tank, and then I'm just gonna um, bring it back. And now I'm just gonna open the vault and see. Okay, now it makes sense in there. So 0.1 moles, this means that your balloon has to be inflated, okay? Not deflated, because it does have 0.1 moles in it. Okay, just make sure about this before you start recording your data. We want the temperature to be 10. Okay, so we want the temperature to be 10 Kelvin. So that is going to be 0. Okay. Here you go. Okay, so that is going to be 0. And now the pressure is going to be 15. Okay. Okay, just make sure that your numbers they line up with the table. Okay, and this one 0. The temperature is very low, so this is why the balloon is deflated, but I had to do that test in there just to make sure that it's working and the cylinder is connected to my balloon. The gas is connected to my balloon in there. Okay, so at a pressure of 15 atmosphere, the volume is that much. You can go ahead and record that. And then what you're going to do is you're going to change the temperature to 1,000 Kelvin. So the temperature here is changed. So we're varying the temperature, we're varying the pressure, and we're studying the effect of that on the volume. And yeah, and then you are going to make the temperature constant at 1,000 and increase the pressure to 15 and record that again. That is going to be for the ideal gas. So for the ideal gas, we did a low temperature, a low pressure, and a low temperature, high pressure. And then a high temperature, low pressure, and a high temperature, high pressure. So we did put all the cases for the ideal gas. After you do the ideal gas, we're just going to return the tank, and we're going to change now into a real gas. So the real gas is that we are going to use our methane and carbon dioxide. So we're going to start with the methane. So just make sure that you pull out the methane cylinder in there. And then after you pull out the methane cylinder, just whatever you see in here, the first one is going to be the pressure 1 atmosphere and the temperature to be 160. So you change the temperature to 160 or pressure to 1 atmosphere, and then you're gonna record the volume, put it over here. Just make sure, put it over here actually. Just again, make sure to save your data. And the reason why I want you every time to save your data, because I will be logging into your lab notebook, so to see your progress in the experiment. So you're going to save your data for me, okay? You don't need it because you're going to get all your information and you're going to plot it right away. We're going to do the same thing for the methane. I think you got the point. We're going to change the temperature, change the pressure, record the volume. After you're done from that, you're going to return your tank, carbon dioxide. Always make sure that the number of moles in there is whatever you need. Okay, so if your number of moles is 0, then we're just going to fill it to, I believe it was 0.1 mole in there. Yes, 0.1 mole. So we're going to open the valve and we're going to fill up to 0.1 in there. Just here you go. And if we filled more, we can go ahead and deflate a little bit. Here you go. So this is going to be your 0.1 mole, and then you can vary the temperature and the pressure and record the volume in there. Okay. After you do this, you are going to use the formula which is PV is equal to nRT. You have all of those. So you can calculate R in there by plugging all the numbers. You can calculate the gas constant for every single one of these cases in there. Okay. Now for the real gas, for the ideal gas first. For the ideal gases, so if you're looking at the ideal gases, I'm expecting the R, your answer has to be 0.082 liter atmosphere mole minus 1, K minus 1. Okay, so these, they need to have the same value for ideal gases. The R, which is the gas constant, should not change. Now, for real gases, the gas constant, the value of the R is going to vary significantly from the ideal gas, which is 0.082. So it's going to be different. This is because at low temperature and high pressure, the molecules, these are close to each other, as we said in real gases, and they do interact with each other. So the molecular volume will become significant in there. So the gas constant is going to change. So this is what you're going to notice. The R for the ideal gas is going to be the same. For real gases, the R is going to be different than that of the ideal gas. It's just going to vary significantly. Okay, guys, so hope this helps. If you have any questions, please let me know.